Alright, hello and welcome. Today I will be walking you through how to use the IFR computed navlog. I will go through basic functions of an IFR Cross Country Flight, as well as the basic functions of completing an IFR training flight using this IFR computed log. So first off, this IFR log is basically just an Excel file. So when you open it up on a computer, it'll be a little Excel icon titled IFR computed log. So when you first open it up, you'll come to this screen. And so this log is broken up into two pages. So this would be the back side, and this would be the front side. So when you print it, you can use this inside the aircraft just like you would the manual navlog. As you can see, the back side looks very similar to what our current manual navlog looks like. So it's very important that before you start using this IFR computed log, they have a very good understanding of how to complete a manual IFR navlog. It's very important that you have a very good background knowledge of how a lot of these numbers are derived before you introduce the technology into the equation and have the technology complete the flight planning for you. So when we come to this page, you'll see that there are two sheets. So the first sheet is the actual software. This is what you input on, the calculations. And the second sheet is the instructions. So you want to make sure that before you watch this video and before you use the IFR computed log, that you go ahead and read these instructions. There's 14 steps to these instructions, and I'm not going to read through all of them right now, but as we go through this training program, I'll be able to touch on each of those instructions. Alright, so to start off, let's move to the top here, and you can see that we have our date. Now, on the program, any box that is white, like these boxes right here, are editable fields. That means you can input actual information into those boxes. The boxes that are colored gray are automatically calculated, and you'll see the little note to the right side. It says this box is automatically calculated. It's very important that anytime you hover over top of a box and before you input information, you want to read the little comment associated with it to make sure that you understand what's being inputted or what needs to be inputted, as well as how certain information is being derived. So to start, the date is automatically calculated based on your computer date. So whatever your computer has for date setting is what's going to be automatically entered here. Then you want to use the drop-down menu, and it says to use the menu to the right, or the little triangle that's upside down to the right of the box. Press that, and you can scroll through until you find the aircraft that you're using today. The IFR computed log currently only serves S model aircraft and does not serve N model aircraft. So let's say today we're going to go for a flight with ZMI. Okay, so then up here you would go ahead and enter the student's name. So let's just say it's me, Hache. I've already entered that. An instructor, let's say that's me as well, Hache. Oops. Okay, so now that we've entered the top part, we're going to go ahead and start with lag number 1. It's very important that while you're completing calculations on this navlog that you go lag by lag. So what that means is you want to complete everything on lag 1, both en route, alternate calculations, and fuel calculations before you move on to lag 2. So to start off, let's say we're doing a trip from here, so Thunder Bay, to Dryden, to Kenora, and then to Winnipeg. So to first start off, I'll put Thunder Bay as my from or my departure destination, or my departure airport. And then in the to slot, I'm going to put my destination airport. So I'm going to put Dryden. And we'll start with just the first lag. It's very important that while you're entering the airport identifier that you don't accidentally put a blank space before the identifier. For example, I'm going to press the space bar twice, and then I'm going to put CYQT. You'll see that it doesn't want to continue with the calculations. To fix that, just highlight the box, press backspace, and re-enter the identifier. Okay, so you can see that I've entered Thunder Bay and Dryden. And the next thing I'm going to enter is the planned routing. So the IFR computed log automatically assumes all of the time that you're doing direct routing. So in this case, it draws a direct line from Thunder Bay to Dryden. This little box right here is merely for personal awareness, and the note to the right side of it says that as well. So it doesn't affect the calculations. So whatever you put in this box, it's just for personal awareness. So let's say we're going Thunder Bay to Dryden, and we want to follow, I think it's the Gulf 6. I might be completely wrong with that. It's probably the Gulf 7 or something like that. But anyways, let's say we're following that airway along our trip. Now the program will still calculate it based off of a direct line, but here we just put for personal awareness. Most airways are based off of waypoints within 5 miles of the departure and destination aerodrome, and so calculations are not going to be really affected by just doing direct routing all of the time. And this is explained a little bit better in the instructions section of the navlog. But anyways, let's go ahead and continue. So the next thing we're going to enter is our MEA. And again, this is also for personal awareness, and this does not actually affect calculations. So I wish I had a load chart in front of me, but I do not. So I'm going to go ahead and just guess at the MEA. And let's say today it's 4,200 feet. So I'm just going to enter 4,200 feet. And again, that doesn't affect calculations. The next thing I'm going to enter is my planned altitude. So you can see there's a little drop-down menu. So I'm going to use the drop-down menu to select my planned altitude. So since I'm heading westbound, I should enter a westbound altitude. Let's go with 6,000. Oops, I accidentally clicked 7,000. And you can see that if I click the wrong altitude based on the cruising altitudes order, it will actually depict wrong altitude to warn the pilot of the mistake. So I'll put 6,000 and wrong altitude disappears. Okay, so the next thing I'm going to do is I'm going to enter the RPM setting. So for 6,000 feet, I think a good RPM setting for us today should be 2,400 RPM. There we go. So it's very important to note that, and it says this in the notes here, that the altitude and RPM setting that are inputted have to make sense with what's listed in the POH. For example, if I was to put 2,000 feet and 2,700 RPM, or even 2,650, the calculations will not process because the POH does not list the ability to attain 2,700 RPM at 2,000 feet. And if I pull it up here, you can see that it doesn't go higher than 2,550 RPM when dealing with 2,000 feet. So we'll go ahead and go back to our original of 6,000 and 2,400 RPM. Okay, so you can see that it automatically calculated magnetic track, and it does so by basically doing a lot of math between the longitude and latitude of these two waypoints and comparing the variation between the two waypoints and adding the average variation, or subtracting it depending on whether it's an easting or westing. The next thing you want to do is add in your wind direction and wind speed. If you don't add a wind direction or wind speed, the calculations will still continue based off of a zero wind condition. So you want to make sure you enter the wind direction in degrees true. So that would be directly from the FDs. So I would enter 340, and let's say at 20 knots. And the software will automatically calculate the magnetic heading, the true airspeed, the ground speed, the distance, and the estimated time en route. So this true airspeed is directly derived from the POH based on 6,000 RPM, or sorry, 6,000 feet and 2,400 RPM. If I pull up the POH, you'll see that all of the numbers are taken from the 20 degree below standard temperature range. So that's where 109 knots is derived from. If I go into, sorry, I put that away, at 6,000 feet and 2,400 RPM, I'm given 109 knots. And ground speed is also calculated, and that's basically just doing an internal E6B calculation in order to derive ground speed. Estimated time en route, if you look at the comment to the right side of the box, what it does is it takes your distance here, divides it by your ground speed, and comes up with your estimated time en route. But then after that, it actually adds on a little bit of extra time to take in consideration your climb to altitude. So that's listed a little bit more in the info page here. And so you can see for a climb to 6,000 feet, it adds 3 minutes onto your estimated time en route. This way it takes into consideration the climb to altitude, because it generally does add extra time onto your trip. Okay, so the next step will be to enter an alternate airport. Now, because we're flying between Thunder Bay and Dryden, I think a suitable alternate for us would be Sioux Lookout. Of course, as long as the weather is suitable to hold Sioux Lookout as an alternate. So now, the next step would be to enter our route. And again, this column doesn't affect the calculations, and it's merely for personal awareness. Generally, if you're flying to your alternate, you're normally doing it in the direct routing, just because it's the least amount of time, and so we will input direct for personal awareness. The MEA will also be for personal awareness, and I don't have a load chart in front of me, so I'm just going to put in a random number. We'll put in 4,500 as an example. Alright, so the next thing does affect our calculations, and that's our planned altitude to our alternate. So let's go ahead and select 5,000. And let's go ahead and say we'll cruise at 2,300 RPM over to Sioux Lookout, our alternate. So you can see that the program automatically calculates my magnetic track to my alternate, which is 63 degrees. And if I don't input anything, it's going to assume 0 wind conditions. But let's go ahead and input the winds of 340 at 20. And I know right now they match the same as are on your calculations, and that's just for ease of input during this example. But when you go and do this for real, you want to make sure that you're checking the upper winds for later in your trip at your alternate, so that you can have the most accurate calculations for fuel. Moving farther down, we got our magnetic heading, our true airspeed, and that true airspeed is taken again from the POH. Now, of course, you can see that the POH doesn't list anything for 5,000 feet. I have 5,000 and 2,300 RPM selected here. So the program will interpolate between 4,000 and 6,000 feet in order to arrive at the true airspeed in gallons per hour. And that is also mentioned in the instructions and information portion of the software. So the next thing would be our distance, and that's automatically calculated at 36 miles between Dryden and Sioux Lookout. We then also have our estimated time en route to our alternate, and this box is derived again from taking our distance to our alternate and dividing it by our ground speed. It also takes into consideration the climb up to 5,000 feet, and in this case it would add an extra 2.5 minutes onto our en route time. So if we continue up here, we'll now look at the fuel calculations, and you can see that the Excel software automatically inputs my gallons per hour for my en route fuel flow, as well as my gallons per hour for my alternate fuel flow. And I'll actually pull this up in the POH so I can show you what's going on here. So our en route calculations were at 6,000 feet and 2,400 RPM. So if I pull up the POH, go down to 6,000 feet and 2,400 RPM, you can see we burn 8.6 gallons. And remember, all of these numbers are always taken from 20 degrees below standard temperature. So I've left with 8.6 gallons. So the software will then take 8.6 gallons and multiply it by 10% of itself. We just do that by multiplying it by 1.1 to give us 9.5 gallons per hour, and that's to satisfy the college SOP. The alternate fuel flow does the exact same thing. So the next thing we want to do is we want to answer this question, and that is, do we need start and taxi fuel? So I think we do, because if we're leaving Thunder Bay, we're going to need to start up and taxi around Thunder Bay. So I'm going to put yes. How many approaches are we planning into Dryden? Well, I'd say probably one. We're not planning much training when we get there, or any training. And you can see that when I inputted information into these boxes, that a couple of things happened down here. So if I was to put no for start and taxi fuel, it would black out this box and it would remove that number from the calculations. Now, you're probably asking, well, why would you ever not need start and taxi fuel? And later in this video, I'll show you why you might not need to include start and taxi fuel. Number of IFR approaches, if I was to put 0, it would black out approach fuel column. But because I put 1, it gives us 2.4. So all of these numbers here are added together to get our minimum fuel required per leg. So let's take a look at each of these numbers and figure out how we came about, or how the software derived these numbers. So 1.4 is there because we answered yes to this question, and 1.4 is taken directly from the POH. The next thing is climb and en route fuel. So climb and en route fuel is derived by simply adding your climb fuel to your en route fuel. So en route fuel is calculated by taking the gallons per hour and multiplying it by your time en route. So that would give us 16.6 if we actually did the math. We would then add it to our climb fuel, which you can see in the little comment box to the right, says that if we're below 7,500 feet in our planned altitude, and of course we are because we're at 6,000 feet, that we're only going to add 1 gallon to our planned altitude, or sorry, 1 gallon to our en route altitude. So 16.6 added to 1 gives us 17.6 for climb and en route fuel. The next box is approach fuel. And if we read the comment to the right, you can see that it says that approaches generally take 15 minutes to complete, and therefore the program will take our gallons per hour, take 15 minutes of it, and it does that by just multiplying it by 0.25, and that comes up with 2.4 gallons. If I was to put 0 IFR approach planned, or sorry, 0 IFR approaches planned, this column is blacked out. If I was to put more than 1, it would just multiply itself by the number chosen. But we'll put just 1 for now, and it'll give us 2.4. So the next column is the alternate fuel. So alternate fuel is derived, as you can see in the formula to the right, by taking the fuel required to climb up to alternate altitude, the time it takes to fly to my alternate, as well as the time it takes to approach my alternate. So the climb to alternate altitude will be 1 gallon because we're below 7,500 feet. Our en route to altitude, or our time to fly to our alternate, will be our alternate fuel flow multiplied by our estimated time en route to alternate. And then after that, we're going to add our approach and alternate fuel, and that's just 25% of 8.8 because that's our alternate fuel flow. And now if we add all those numbers together, we get 6.6, and that's our alternate fuel for holding Sioux Lookout as an alternate. The next box will be our legal reserve, and our legal reserve is always 6 gallons. And this is based off of 45 minutes, or 75% of 8 gallons an hour. 8 gallons an hour is the fuel flow for 4,000 feet and 2,300 RPM from the POH. And this is a constant value. 2,300 RPM and 4,000 feet is a good number to be using for legal reserve calculations. Now, if we come down here, if at any point you want to add any extra fuel into this calculation, you just add it right here. That could be for holds, delays, whether it be weather delays or ATC delays, or just a bit of extra granny gas. And let's add 2 gallons today. Okay, so you can see that the minimum fuel required now for this leg number 1, will add up this number, this number, this number, this number, this number, and this number to get 36 gallons. So the minimum fuel required for only leg 1. So the next column is asking us if we plan on refueling when we get to Dryden. Well, since we're planning to go all the way to Winnipeg, we might need to get fuel along the way, but for now I'm gonna put no. And right now it's not giving me any preferred fuel for the start of this leg. The reason for that is right now my preferred fuel is just my minimum fuel required. I haven't inputted anything in my second leg yet, and so nothing is going to show up here until I start inputting stuff into my second leg. So right now, if I just wanted to go Thunder Bay to Dryden, holding Sioux Lookout as an alternate, it would take me 36 gallons. So we're going to go ahead and we will now complete the second leg. But before I complete the second leg, I want to show you the other automatic calculations that are done down here. And this is what it does when it calculates endurance time into alternate. And so what it does is this is very similar to the manual navlog, and the only difference is all of these numbers are automatically calculated for you. And so your estimated time en route to alternate is taken directly from this number. Time for approach at alternate is always 15 minutes, and legal reserve is always 45 minutes. So adding all those numbers together, we get an hour and 22 minutes, and that number is automatically transferred to the backside. Okay, so now we will start talking about leg number 2. So this leg, we will be going from Dryden to Kenora. What route do we plan? Well, again, the program automatically assumes direct. So you can put, again, whatever you want in this column, but I'm just going to put direct. Again, it's only for personal awareness, this column. Let's go ahead and make up an MEA. Of course, if you had a load chart in front of you, you're going to put the accurate MEA in that box. Planned altitude, let's go at 4,000 feet for this leg. Let's go at 2,300 RPM. Let's, just for ease of example, we'll put the same winds. Coming down here, when we go to Kenora, on this leg, what should our alternate be? Well, why don't we use Red Lake? Let's go ahead and input direct, 4,500, just for, again, that's just a made up number here, the MEA, you'd have to check with the load chart. Planned altitude, let's go at 3,000. Let's pick an RPM setting of 2,550. And let's say the winds are calm on this leg, so I'm not going to put any winds information at all. Okay, so we come up here, again, focusing on leg number 2. Do I need start and taxi fuel? Yeah, I think I'm going to need to start and taxi while I'm in Dryden, so we'll put yes. How many approaches are we planning? We're probably planning only one approach in Kenora. Okay, so it's going to add all these numbers together for me. And it's going to, should I put some additional fuel? Yeah, let's go ahead and throw 2 gallons in there. So right now, the minimum fuel required that's listed right here is only adding leg number 2. So it's adding 1.4, 7.1, 2.3, 11.5, 6, and 2 to come up with a number of 30.3 gallons. So the next question it's asking me is, am I going to refuel in Kenora? So it's asking me, do I plan on refueling in Kenora before I continue on the way to Winnipeg? Let's go ahead and answer no. So now you can see preferred fuel numbers are arriving at the bottom here. So this is basically a suggestion as to how much fuel you should put on board the aircraft before you leave Thunder Bay. this is how much fuel you should put on the aircraft before you leave Kenora, or I apologize, before you leave Dryden. So this number right here is calculated by adding the start and taxi fuel for both, the climb and en route fuel for both, the approach fuel for both, but it only takes in consideration one of the alternates. So in this case, it takes in consideration larger alternate 11.5 gallons. It also only takes in consideration one of the legal reserves, so it only adds in 6. And it takes in consideration, though, both of the additional fuel boxes. The reason it only takes in consideration one of the alternates and one of the legal reserves is just the way fuel planning works. Is if I added alternate fuel for both, I'm going to leave Thunder Bay with way too much fuel, way more fuel than I need. Because if I end up making it to Dryden, I'm never actually going to use Sioux Lookout as an alternate. So this is how preferred fuel is derived, by adding start and taxi fuel for both, climb and en route for both, approach fuel for both, only the larger of the two alternates, as well as only one of the legal reserves, and it adds both of the additional fuel boxes. Coming over to preferred fuel for the start of leg 2, you can see it's the exact same as the minimum fuel required for that leg. It's the same right now because I haven't inputted anything into leg number 3. So I'm going to go ahead and enter I'm going to go ahead and enter information now into leg number 3. But before I do that, I'm going to show you what would happen if I decided to refuel in Dryden. Okay, so now you can see that preferred fuel is 36, and it's actually the same amount as my minimum fuel required. So the minimum fuel is 36 to take me to Dryden, holding Sioux Lookout as an alternate. I'll fuel up in Dryden with 30.3 gallons, and that'll take me to Kenora, holding Red Lake as an alternate. Alright, so now we're going to go ahead and enter our third leg. So we'll put in Kenora to Winnipeg. I'm not going to bother inputting anything in the route and MEA. I think you guys get the idea of these boxes and how they don't affect calculations. So we'll go ahead and input an altitude. Let's go with 8,000 for this one. Let's go with 2,500 RPM. Let's input the winds at, again, 340. 20 knots. It does all the math for me, so it should take me about an hour and 9 minutes to fly from Kenora to Winnipeg. Let's hold Kenora as an alternate. So if we don't make it into Winnipeg, we'll just come right back to Kenora. Again, these boxes are for personal awareness. I won't fill them out on this leg. We'll throw in our planned altitude of 5,000 feet for our alternate. Let's go with 2,400 RPM. And let's just assume the winds will be light on the way back to Kenora if we miss in Winnipeg. Coming back up here to leg number 3 fuel calculations, I have my en route gallons per hour as well as my alternate fuel flow in gallons per hour. Do I need to start and taxi in Kenora? Yes. How many approaches do I plan in Winnipeg? We'll go with 1. Okay, so it does all the math for me. So if I was just doing Kenora to Winnipeg and holding Kenora as the alternate, I would need 36 gallons. If I had put in an extra 3 gallons of additional fuel, I would need 39 gallons. So it doesn't give me the option to refuel at the end of my Winnipeg leg because it won't affect calculations in any way. So coming back down here, you can see that now that I have chosen not to refuel in Kenora, if I left Kenora and wanted to make my way to Winnipeg, when I leave Dryden, so when I leave Dryden, which is the start of my second leg, I would need 51.8 gallons. So if I decided to not refuel at all along the trip, I would need 75.2 gallons leaving Thunder Bay. Now, of course, our aircraft do not have the capacity for 75.2 gallons, and there is no warning feature to let you know that the fuel calculations don't work for that, and so that's just a pilot awareness that the fuel number does not actually work for our aircraft, because we can't carry 75.2 gallons. Okay, and again, also the endurance time to alternate will automatically transfer the numbers listed down here, as you can see, and it'll transfer the totals to the back page. Okay, so the next thing I want to show you is how to complete a computed log for a trip to a destination like Marathon. So if I'm leaving Thunder Bay and I'm headed towards Marathon, the program will want to draw a direct line between Thunder Bay and Marathon. But if I do that, I would be exposing myself to the hazard of gliding distance in our 172 aircraft. So generally, when you fly a trip from Thunder Bay to Marathon, you go via Nipigon along the shoreline. So if you look on a low chart, over top of Nipigon is a waypoint called Bilii, and that's in the database here in the program. So in order to do a trip to Marathon, I would input Bilii, Thunder Bay to Bilii as my first leg, and you always want to make sure you spell it correctly. There we go. And the second leg would be Bilii to Marathon. So the first leg, Thunder Bay to Bilii, will be, I believe, the Victor 13 eastbound. And the MEA is as required, whatever you want to put there, corresponding to the low chart. We'll plan an altitude 5,000, altitude RPM setting of 2,400. We'll say the winds are calm. And for this here, you are not required to enter an alternate for the first leg, because all you're doing is flying from Thunder Bay to Bilii, which is over top of Nipigon. Coming up here, staying with leg number 1, it's asking, do you require start and taxi fuel? Yep. Am I planning any approaches? I'm going to put 0 because I'm not really planning any IFR approaches at Bilii. That's just a transition waypoint. So then it does the math, start and taxi fuel, climbing on route fuel, comes up with a minimum fuel required, but this actually doesn't mean anything to you right now because we are doing a trip via Bilii to get to Marathon. So minimum fuel doesn't mean anything to you right now. What we're going to look for is preferred fuel, and this will make more sense once I enter leg 2. So leg 2 is Bilii to Marathon, again following the Victor 13. MEA would be as required. We'll put our altitude at 5,000 and 2,400 RPM. And we'll say the winds are light. And because we're ending in Marathon on the second leg, we would need an alternate, and we'll say our alternate will be Geraldton. The route would be as required, MEA as required. We'll say that we head to Geraldton at 4,000 feet if we miss in Marathon, at an RPM setting of 2,300. And just for ease of example, I'll leave the winds at 0 as well. So, for the second leg, do I need start and taxi fuel? I'm going to put no, because remember, the second leg is starting over top of Bilii, where we're already at 5,000 feet, so there's no requirement for start and taxi fuel. However, when it comes to number of I.F.R approaches, we will put 1, because that's the approach we need to get into Marathon when we arrive at our destination for leg 2. Okay, so all the math is done for me, and these two numbers down here are not going to be used for this particular flight. And that's because we're going Thunder Bay to Marathon via Bilii. So this is really just one trip, but broken up into 2 legs because I have to go via that transition waypoint. So I'll need to come down here and answer these questions. Do I plan on refueling in Bilii? That'll be a no. Do I plan on refueling in Marathon? That'll be a no as well. So now you can see that this number right here is the amount of fuel that is required for me to go to Marathon via Bilii, and if I miss a Marathon, to go to Geraldton. And that is calculated by adding a few of these numbers together. So it adds the start and taxi fuel out of Thunder Bay, 1.4. It adds the climb and en route fuel to get to Bilii and then to get to Marathon. So plus 6.2 plus 7.8 plus the approach in Marathon, 2.4, plus the amount of fuel to get to Geraldton if I miss in Marathon. And then it would add in only one of the legal reserves, so plus 6. So it gives me 32.9. So that is the amount of fuel that I would need to leave Thunder Bay with. And if I'm working with endurance time until alternate, you do not need to use leg number 1 for your calculations. So you'll only ever use leg number 2 in this case, because again, remember, leg number 1 is just going to a transition waypoint. Okay, so now that we've finished talking about IFR cross countries, we will now examine how to use this IFR computed log for a local training flight out of Thunder Bay. So to start off, again, you would fill out the top portion with the information required. And to start, you would enter Thunder Bay as your departure airport. It's important to note that with an IFR training flight, you'll only ever use leg number 1 and leg number 2. Leg number 3 will not be used for an IFR training flight. So generally, most IFR training flights, when they originate in Thunder Bay, will depart northbound, southbound, westbound, eastbound, whichever direction is desired, along a specific airway. For example, a flight might take Bravo Romeo 9 northbound. And generally, the departure procedure lasts about 25 miles. So you'll head 25 miles north of Thunder Bay along the Bravo Romeo 9. And at that 25-mile point, you'll turn around before heading back to Thunder Bay for a hold and 2 approaches. So the way the program is designed, the leg 1 will act as the first 25-mile journey out to that waypoint, and then leg 2 will be that journey back to Thunder Bay for the hold and 2 approaches. So for the destination for the first leg, I'm going to put LCL space BR9. And what that is it's a code that basically places an imaginary waypoint approximately 25 miles north of Thunder Bay along the Bravo Romeo 9. And if you open up the instructions and info, you can see that all these codes are listed under step 14, depending on the airway or air route that you're trying to fly along. So the first leg will take us from Thunder Bay to that imaginary waypoint 25 miles, or approximately 25 miles, north of Thunder Bay. And for route, again, this is just for personal awareness, but we are using the Bravo Romeo 9 today. MEA, you'd enter whatever the MEA is for the Bravo Romeo 9. Planned altitude is whatever you plan on heading out there at. Let's say we're going to plan at 5,000. And we'll go with an RPM setting of 2300 RPM. So we have a magnetic track of 4 degrees. We have a wind direction we can say is 320 at 20 knots. Okay, so as you can see, with the winds inputted at 320 20 knots, we have a ground speed of 87 knots, and it should take us about 21 minutes to head out to that imaginary waypoint along the Bravo Romeo 9. So the next step would normally be to input the alternate calculations. But because we're doing an IFR training flight, we're not going to input the alternate calculations for the first leg. So we can leave that blank. And this will make a little bit more sense later in the video. So coming up to the fuel calculations, so we have our en route fuel flow, and of course because I didn't input any alternate calculations, we do not have an alternate fuel flow. Do I need start and taxi fuel? Yep, because we are taxiing to depart Thunder Bay. How many approaches am I planning? Well, the thing you need to remember with this log is that for an IFR training flight, the first leg is just getting out to that imaginary waypoint. So the first leg is ending at that imaginary waypoint along the Bravo Romeo 9. So we're not actually planning any IFR approaches, and that's why we have the option of 0. And when we plan on coming back to Thunder Bay, that's when we will input the number of approaches we are planning. So, as far as fuel planning goes, the minimum fuel required for the first leg doesn't really mean anything to you for an IFR training flight. Do we plan on refueling when we get to that imaginary point? No, we do not. So for now, we'll stop there and we'll move over to leg number 2, which is coming back to Thunder Bay for our hold and 2 approaches. So what I'll do is I'll input departing from that imaginary waypoint and arriving back in Thunder Bay. The route, you can just leave blank, the MEA as required, and planned altitude, we'll say we're heading back at most likely the same altitude. Now of course it will give me the wrong altitude warning, but because it's an IFR training flight, the altitude doesn't matter as much for the inbound portion to Thunder Bay. We'll put in the same RPM setting, and we'll make sure we put in the same winds. Okay, so you can see that it calculates that it should take me approximately 16 minutes to fly back to Thunder Bay at 118 knots. So now this is where we want to input our alternate. So we will input an alternate that works based on weather. Today let's use Geraldton as an alternate, and we'll assume that Geraldton works as a valid alternate based on the weather. So our route to Geraldton, if we need to use it, can be whatever you want. Let's just say direct. The MEA would be as required. I'm going to leave it blank because I don't have a load chart in front of me. Planned altitude, we'll say we'll probably head over to Geraldton around 5,000 feet if we miss in Thunder Bay at an RPM setting of 2400. The winds, we'll say if we do miss and have to go to Geraldton, are going to be light. And so that should take us about an hour and 9 minutes to go to Geraldton if we miss in Thunder Bay after our training flight. So coming now up to the fuel calculations, it asks me, do I need start and taxi fuel? And I'm going to answer no, because remember, leg 2 is starting at that imaginary waypoint in the sky 25 miles north of Thunder Bay along the Bravo Romeo 9. Number of I.F.R approaches planned? We'll plan 2 approaches for training purposes when we get back to Thunder Bay. Okay, so as we come down here, additional fuel for holds and delays. Well, we're probably going to plan a hold for training purposes, and we'll say that hold will be about 20 minutes, and we'll put 4 gallons of fuel for that hold. And you can again put whatever you want in here for that hold in terms of how much fuel you want. So Because it's a training flight, these numbers right here do not really mean anything to you. The number you're going to be looking for is the preferred fuel number. So now it's going to ask if I'm going to refuel when I get to Thunder Bay, and that'll be no, because I can't refuel in the middle of a training flight. Okay, so it gives me 37.2 gallons. Now this is the number the amount of fuel that you require for your training flight. And the way this is calculated is it adds in start and taxi fuel for when you first start. It adds in enough fuel to get out to that point along the Bravo Romeo 9, and enough fuel to get back to the Thunder Bay. It adds in fuel for those 2 approaches. It adds in enough fuel to get to Geraldton if I miss, and it adds in only one of the legal reserve numbers, so it adds in just 6 there. And it adds in 4 gallons for additional fuel. And if I pull up a calculator, I'll actually do the math here to show you. So we'll add in 1.4 plus 3.8 plus 3.1 plus 4.4 plus 14.5 plus 6, again only taking one of the legal reserves, plus 4 equals 37.2. So for your training flight, you'll require 37.2 gallons. And again, remember that leg number 3 will not be used for calculations for an IFR training flight. Now, if you're curious as to how this actually works, if I open up this other version here, what I've done is I've opened up a second version, which is actually the unlocked version, to show you how information is derived. So, on the nav log that will be available to staff and students, everything is locked. It's protected so that you can't accidentally erase formulas. But this unlocked version, you can see that behind each of these boxes is an underlying formula. And if we pull up sheet number 2, you can see the software behind all of the calculations. You can also see the database for the airports and NDBs and VORs that are currently inputted into the Excel program. So this is the software code. So it's nearly 250 lines of code that tells this program how to work. If I go to sheet number 3, this is the POH data. So it lists all of the numbers from the POH directly from the S model POH, as well as does some other math and calculations over here on this side of the sheet.